This is Shadow Mind Investigation 001, the science of fear. What if the scariest thing about fear isn't the thing you're afraid of? What if it's how little control you actually have once it starts? Somewhere right now, someone is about to feel it. A shadow shifting in a dark hallway, a car swerving into their lane, a sound behind them that shouldn't be there, and before they even understand what's happening, their body has already decided. Not their mind, their body. By the time the thought "I'm scared" arrives, the war is already over. Here's the part almost nobody knows. Fear doesn't start in your head. It starts in a structure the size of an almond, buried deep in your temporal lobe, and it moves faster than thought itself. Neuroscientist Joseph Ledoux discovered that when your eyes catch something threatening, that information splits and travels two different paths at once. One path is slow. It runs through your visual cortex, gets analyzed, gets context, gets understood. That path takes around 200 milliseconds. The other path skips all of that. It goes straight from your eyes to your amygdala, bypassing the thinking parts of your brain entirely. Ledoux called it the low road. Crude, fast, reckless, and it can complete its work in as little as 12 milliseconds. 12 milliseconds. That's faster than you can blink, faster than you can register a single word on this screen. Your amygdala has already sounded the alarm, before your conscious mind even knows there's something to be alarmed about. This is why you flinch at a coiled garden hose before you realize it isn't a snake. Your brain isn't waiting to be sure. It's built to react first and verify later, because for most of human history, the cost of hesitating was death, and the cost of overreacting was just a little embarrassment. So what happens next? The amygdala doesn't just sound an alarm and stop there. It sends a signal to the hypothalamus, which activates your sympathetic nervous system, and within seconds your body is a completely different machine than it was a moment ago. Adrenaline floods your bloodstream, your heart rate climbs fast. And here's where it gets specific, almost mechanical. At around 115 beats per minute, you start losing fine motor control, the kind of precision it takes to thread a key into a lock. Push past 145, and complex motor skills start to fail too, the coordination between your hands and your eyes falling apart. But somewhere around 150, something strange happens. Your raw strength and speed actually increase. Gross motor skills sharpen even as everything precise collapses. And if your heart rate crosses 175, the system doesn't just struggle anymore, it can break down completely. Your pupils dilate, light floods in, but your field of vision narrows into something researchers call tunnel vision, and you lose your peripheral sight almost entirely. At the same time, your hearing can partially shut off. It's called auditory exclusion, and it explains something that sounds almost impossible. People in life-threatening situations have reported not hearing gunshots, not because the sound wasn't there, because their brain decided in that instant that hearing it wasn't going to help them survive. Blood moves away from your skin and your digestive system, which is why you go pale, why your mouth goes dry, why your stomach seems to disappear entirely. That blood gets redirected to your major muscles, the ones that might have to run or fight in the next few seconds. There's something else happening in this same instant, something scientists only recently connected to fear at all. Deep in the amygdala, a separate circuit reaches toward your liver and triggers an immediate spike in blood sugar, completely independent of the adrenaline already flooding your system. Researchers studying this pathway found something else, something almost unsettling. If the same stress hits you again and again, that circuit starts to go quiet. The blood sugar spike gets smaller each time. Your body, it turns out, can learn to stop fully arming itself, even while everything else about the fear response stays exactly the same. And your frontal lobe, the part of your brain responsible for judgment, for weighing options, for rational thought, actually goes quiet too. Not because it's broken, because in a genuine emergency, thinking is slower than reacting, and your brain has already decided which one keeps you alive. But here's where the story gets strange, because not everyone fights, not everyone runs. Some people freeze completely. And for a long time, freezing looked like failure, like weakness, like a system that simply broke under pressure. It isn't. Freezing happens early, the instant a threat is detected, and it exists to make you harder to notice in the first place. Stillness reads as invisibility to a predator's eye. But there's something even stranger beyond freezing, a state called tonic immobility. This is different. This happens after a predator has already made contact, when escape genuinely isn't possible anymore. Your muscles lock. Your heart rate can actually slow down instead of speeding up. Some researchers believe this state exists because playing dead can reduce a predator's interest, and because dissociating from the moment can blunt the pain of what's about to happen. It's not a decision, it's a switch, buried deep in your nervous system that your conscious mind never gets a vote on, which means the 4 responses you've probably heard of: fight, flight, freeze, and a 4th one called Fawn, where a person under threat becomes agreeable, almost eager to please their attacker, aren't really 4 choices. They're 4 different outcomes of the same ancient system, deciding on your behalf, faster than you could ever decide for yourself. Here's the part that should genuinely unsettle you. This entire system, the 12-millisecond alarm, the flood of adrenaline, the narrowing vision, none of it was built for the world you actually live in. It was built for a world of claws and teeth and cliffs, a world that mostly stopped existing thousands of years ago. But the alarm never got the memo. In people with anxiety disorders, researchers have found the amygdala firing on almost nothing at all, mistaking a harsh email, a silence in a conversation, a phone buzzing at the wrong moment for the same kind of danger that used to mean a predator in the grass. The system doesn't know the difference between a genuine threat and a modern inconvenience because it was never designed to. It was designed for speed, not accuracy. Think about what that actually means. Somewhere inside you, right now, sits a threat detection system inherited from ancestors who never saw a car, never heard a gunshot, never once needed to worry about a deadline or a difficult conversation. And that same system still runs the show. Your body can't always tell the difference between a predator in the dark and a notification on your phone. To your amygdala, both can register as danger. Both can trigger the exact same 12-millisecond alarm. This is Investigation 001. And the deeper you look into fear, the less it looks like an emotion, and the more it looks like a survival algorithm running underneath everything you think you are. Older than language, older than reasoning, older than you. Shadow Mind Investigation 001 completed.